All right, so finishing up some examples on how to use your calculator. So, absolutely must have a calculator for the trig unit. Okay, if you've been sharing, you need to find one that is yours because every calculator works different. And if you don't want to get into a different get into a calculator that works differently when you get into a test and exam situation. So important. Okay, so in the old days before calculators, there were sheets and reams of sheets where you'd have to go look this up. Because remember, the trig ratios, they are a constant, tan 45. All 45-degree triangles have the same ratio. So your grandparents would flip through pages looking for what was tan 45 equal to. We've converted those pages to your calculator. Your calculator has memorized those pages. It is doing no calculations when you hit the sine, cos, and tan button. So on your calculator, you need to locate sine, cos, and tan. So mine are sin, cos, and tan. That's what they'll show up as. Remember, it's pronounced sine, cosine, and tan. So you need to find those buttons on the calculator. Again, when I type in tan 45 on my calculator and hit equals, oops, what's going on here? So try that one more time. Tan 45. Oh, mine's the other way around, I guess. So clear. So 45 tan. Oh, my calculator's a little bit more backwards. Okay. So tan 45, you should get a value of 1. So there are two types of calculators out there, and that's as I'm finding with mine. So type 1. If you have a type 1 calculator, you would hit your tan button. You would then punch in 45, and then you'd hit equals, and you would get 1. So that's calculator type number 1. Calculator type number 2, this goes back to similar to the one I just had on the computer, which is kind of surprising. You have to type the angle in first, then you hit tan, and then your answer automatically comes up. All right, so that's your answer. So you don't have to hit the equal sign. So there we are. So remember, when you typing this into the calculator, and we'll do cos of 53. So 53. I'm going to tell the calculator, just go look in your memory. It's doing no calculations here. It just says, hey, every 53-degree triangle has a ratio of 0.6018. 6018. You want to go to 4 decimal places. That's the kind of the accepted norm here. All right. So the calculator is simply recalling memorized information. That's all it's doing. So the last one, go tell me what you memorized about sine or the angle 78 degrees. And we know that the opposite divided by hypotenuse, 9781. 9781. Remember that sine theta is opposite divided by hypotenuse. So that means that every triangle that has 78 degrees, if you take opposite divided by hypotenuse, it's always 0.9781. Always. That's what that's telling us. Okay? So please figure out which calculator you're working with. Okay, those are the two types right there. And make sure when you go do the homework, you do practice with it. Because like I said, every calculator is a little bit different. What happens if we want to know the angle associated with the ratio? So down here, we know that the ratio is 0.5673. So that's saying that I have a triangle. So I'll just quickly draw it out here. Hypotenuse, I'm going to say that's theta, opposite, and adjacent. I know that the sine of the angle, O over H, I know that O over H is 0.5673. Calculator, can you tell me what angle opposite over hypotenuse is always 0.5673? Okay, so again, it's not doing any calculations. All right, so with my calculator, you need to find your second function or your inverse function on the calculator. So I'm going to hit my INV button for this one. So I will punch in this. I have a calculator type number 2, 0.5673. I'm going to hit my inverse button, INV. Some calculators will be second. And now you'll see that my sine, cos, and tan have changed to the -1s. If you look on your calculator in a little different colored ink above the button, you'll see that you have the same -1s on sine, cos, and tan. So that's saying do the inverse. Go the opposite direction. then we end up with 34.6. So we would write it as A equals 34.6 degrees. All right, so it's just looking it up in the chart. Okay, so the two types of calculators. Type number one, you will hit second or inverse INV, depending on what you have on your calculator. Then you'll hit the trig function in question, and then you will put in your decimal, 0.5673, and then you'll have to hit equals. So that's calculator number one. Calculator number two, I'm running out of space, so I'm going to kibosh that. So calculator number two, I had to enter in my decimal first, 5673. I then hit my second or inverse button, depending on your calculator, and then you hit the function in question, and the answer automatically spits out. So those are your two types of calculators. Please make sure you figure out which one you have. All right, let's try this next one. So, get my calculator up. I am doing 0.5673, so 0.5673, oops, 5673, and I want to find inverse tan. I'm looking for the reciprocal, okay, the reciprocal. So inverse tan, and I get 29.6 degrees. So B equals 29.6 degrees. And there we are. So as we move into some examples, using trig ratios, find the angles in the right triangle. So we're going to start by finding angles. So I'm going to call this, and you can stick with A and B. I'm not too upset if you do that. Find a reference angle. So I'm going to pick this as my reference angle. All right. I'm going to stick with the Greek letters. That's what I'm comfortable with. So what do I know? So first thing you have to label the triangle. I can't stress this enough. This is the hypotenuse. This is not a lot of work. Writing 3 letters, not a lot of work. So don't give me this too much work thing. So hypotenuse is across from the right angle. This has to be the opposite side because it's opposite of the theta or the angle that I've picked. And this has to be adjacent. Now, you could pick A and you'll get the same answer. It doesn't matter which one you pick. All right, doesn't matter. So I have to ask myself, what 2 sides do I know? Because I'm going to write SOHCAHTOA up here. And this is the mental process you're going through. I am given O and I am given A. Which trig ratio has O and A? I have O and H, A and H, O and A. This is it right here. So that means I am using, for this question, tan theta. So tan theta equals, the primary trig ratio is opposite over adjacent. Tan theta equals, opposite over adjacent would be 6 over 10. Now, this is a must for the grade 10 course. I need you to get into the habit of writing this. Theta is equal to tan, and we put the exponent -1 of 6/10. All right, in grade 11 and 12, we let you drop this, but it's so important for you to recognize that this is an inverse operation. So I am going to make you draw that line in for me. So theta equals tan inverse of 6/10. Now you can go to the calculator and you can calculate it. If you can't set this up, there's no sense worrying about the rest of the trig unit here. So it's very, very important. I see your process. Make sure you understand it. So how do you do 6/10 with a fraction? I'm going to use a bracket and do 6 divided by 10. Every calculator has a bracket. And then I'm going to hit inverse because I want to know the angle, tan. So my angle at corner B, theta, equals, lost it there, 30.96. Let's call that 31 degrees. Close enough for me. All right. How do I find angle A? Well, angle A is just 180 degrees in a triangle, minus 90. That's the given angle, minus the one we just calculated, the 31. So I'm down to 90 minus 31, so I get 59 degrees. So there are my 2 answers. Okay, you don't have to do trig ratios again, all right? Doesn't matter to you can, but it's really causing a little extra time. All right, so the next one. The angle is provided here. It tells us that's theta. That's the corner. Here's my reference angle. I know that my 90 is there, so this is hypotenuse. This is the opposite side. Last side has to be adjacent. What two sides do I know? I know opposite, O, and I know H. Sine has an O and H, so I have to use the sine function for this particular one. So I know sine theta equals O over H. Sine theta equals 3 over 7. Theta equals sine inverse. That shows me that you understand it's an opposite or an inverse operation. Now you can go to the calculator. You really have, at this point, if you do those three lines for me, you've got a level 4. All right? If you can't use the calculator, I'm going to have to send you some remedial school on how to use a calculator. That's the best I can do for you. So, but I'm more worried in your thinking process here. Very, very important. So again, I do the 3 divided by 7 with the calculator in brackets, looking for an angle, so I have to hit inverse. And I hit the sine function, and I get 25.4 degrees. So theta equals 25.4 degrees. So there's my first answer. Now I can find the other answer. And I'm just going to put a Greek letter up there to make life easier. So phi is equal to 180 minus 90. And some people are going to say, well, isn't it just 90 minus the angle all the time? Yes, it is. So we have 90 minus 25.4. Which is 64.6 degrees. There we go. So there are two answers for that particular question. Moving on to the last set of examples, I believe here. So, using trig ratios, we want to find using trig ratios to find sides in the right triangle. Still, this one's going to take a little bit more work. I'm going to finish this up with the third video. It does take a little bit longer to get through this. I apologize. And then we'll go through a couple of tips. So this won't take too long in the last video.